Hi, this is Alan with Bothell STEM Coach, and today I'm going to start a new series on topical problems for calculus. So we're going to be doing in this video some related rate problems because I want to target some of the more challenging topics that a lot of my students run into, and related rates is definitely one of them. And at this point in the year, related rates is should have been covered already or just wrapped up. Or doing it just now. So I'm going to go through a few sort of difficult, more challenging related rate problems, and just make sure you know how to approach them. With related rates, the hard part is not actually the calculus. The hard part is usually the setup, which may rely on some geometry, trigonometry, or algebra that you haven't done in a while, and that's, I find, what makes it the most difficult. For a lot of students. So let's get into this first one here. As usual, I suggest you try to pause the video, read the question, attempt to do it yourself, and then come back after you've tried the problem. So I have a ladder with length 15 feet is leaning against the wall and it's sliding down the wall at a rate of 1 inch per minute. How fast is the area under the ladder changing when it's 5 feet away from the wall? Now this is a classic problem, but normally, so let's kind of do this setup here. I have a ladder, it's leaning against the wall. Remarkably looks a lot like a triangle. And it's 15 feet. Okay, and it's sliding down. And a lot of times the question is how is this sliding? But I'm not asking it in this question. This is my own question. I'm asking how is the area changing? The key part for related rate question is you want to put some variables and you want to figure out what you're trying to solve for and find an equation that relates the variables of interest, okay? So what are some interesting things here? Well, there's this height of the wall, because what I'm giving you, so we already have the length of the ladder is 15 feet here. We're giving that dh dt. This is dh dt right here. It's sliding down the rule. Because it's sliding down, and I'm going to say height is positive, sliding down at 1 inch per minute, this is minus 1/12 feet per minute. The other thing about related rates is you need to be careful. You want to make sure everything's in the same units, and I'm going to pick feet because most of these are in feet. Okay, so dh dt is given by that. The question is dA dt. How is this changing? And I need to find and I need to find this when it's 5 feet away from the wall. Let's call this x, when x equals 5. So I want to find an equation that relates a, h, and x in some way. Okay? So the first thing is well, I know area of this triangle is 1/2 base times height, 1/2 xh. Okay? So if I take the derivative of this, dA dt, and I'm doing the derivative with respect to time. Now, the x times h, I got to do product rule, because both of these are going to change with time. See, none of them are constant. So, by product rule, it would be x dh dt plus dx dt h. Okay? Now, I know dh dt already, and I know x, but I don't know h and dx dt. Like these quantities I don't know. So here I'm stuck a little bit. You know, I've got my equation, but I need to figure out what these quantities are. Well, fortunately, there's an equation that relates x and h, and I haven't used the fact that it's 15 feet. And what relates x and h is the Pythagorean theorem. Because I know x squared plus h squared equals 15 squared. Okay? So this lets me figure out both of these things, actually. I can figure out h, because I know if x is 5, when x equals 5, then I have 5 squared plus h squared equals 15 squared. And so h squared is equal to 15 squared minus 5 squared. That's 225 minus 25, which is 200. So h is equal to the square root of 200, which is 10 root 2. Okay, so now I know h is 10 root 2. I know x is 5. I know dh dt is negative 1/12. To find dx dt, I need to take the derivative of this equation, because I need another equation that has dx dt, and one way I can do that is take the derivative of this equation. This, I would do 2x dx dt. And the reason you take the derivative with respect to x with respect to time is that you think of x as a function of time. So I do 2x because that's power rule, but since the inside is not t, I multiply by the derivative of x with respect to time. Okay, this is chain rule. The reason this is chain rule. Plus 2h dh dt, and the derivative of 15 is 0 because that's a constant. So I can solve for dx dt. dx dt is equal to negative h dh dt over x. And negative h, let's see, we said h was 10 root 2. dh dt is negative 1/12. And x is 5. So dx dt, let's see, this 12 comes, let's say this would cancel and become 2. That can cancel with that and become 6. The negative cancels with that. So I get root 2 over 6. That's dx dt. And so now I can finally, I figured out all the missing pieces for my dA dt. It's 1/2. X is 5. dH dt is negative 1/12. dx dt is root 2 over 6. And h is 10 root 2. It's equal to 1/2 times, let's see, this is negative 5/12 plus, that becomes 2, that becomes 5 and 3, so 2 times 5, that's 10 over 3. Times 4 would be 40 over 12. 40 minus 5 is 35, so that's 1/2 times 35 over 12, which is equal to 35 over 24. And the units of this are feet squared per minute. Okay? So I hope you found that helpful. We'll be doing more problems like this, so you'll see more videos doing more related rate problems. But hope you found it helpful. I'll see you all in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.